Hello everyone, I'm Rajasri, Assistant Professor, Department of Electrical and Electronics Engineering, MLR Institute of Technology, Hyderabad. And in today's lecture, I'll be discussing problems on single-phase half-wave controlled rectifier. And here we have a problem for the circuit shown in figure. If average output voltage is 50 volts, then find the firing angle. Firstly, for any problem given, we need to write down the given data so that it will be easy for us to solve the problem. And for the circuit shown here, average output voltage is given as 50 volts. And here, source voltage is equal to Vs is equal to 200 into sine 314 into T. And here, where Vm is equal to 200 from this particular value. And here resistance value is given as 2 ohms and inductor value is given as 5 millihenry. And here for this circuit, he is asking you to find out the firing angle. And it is clearly with RL load, with freewheeling diode, single phase half wave controlled rectifier. And we have the formula as V0 average is equal to Vm by 2 pi 1 plus cos alpha, where V0 average is given in the formula. Only thing we need to find out the alpha, where V0 average is equal to 50 volts and where Vm is equal to 200, it is directly given by 2 into pi 1 plus cos alpha. And if you solve the problem, resolve this and obtain the value of alpha, alpha will be equal to 55.14 degrees. This is how we can find out the value of alpha. And the second problem, an SCR is used to control the power of 1 kilowatt, 230 volts, 50 Hz heater. Determine the heater power for firing angle of 45 degrees and 95 degrees. So here let us write down the given data, and this is clearly this is a single phase half wave controlled rectifier with R load. And for this, let me write down the given data. Here Vs is equal to, it is given as 230 volts, and similarly power is equal to 1 kilowatt. Frequency is 50 Hz. Determine the heater power for firing angle of 45 degrees as well as 95 degrees. Here he is asking us to find out the power. How to find out this power at 45 degrees and 95 degrees? Power is equal to V0 RMS square divided by R. And in order to find out this power at 45 degrees, we need to find out the value of V0 RMS as well as value of the resistor. Let us first write down the formula for V0 RMS. For single phase half wave controlled rectifier, the formula we have is Vm by root 2 into pi minus alpha plus sine 2 alpha by 2 whole to the power of 1 by 2. And here Vm is equal to root 2 Vs. This is single phase. Vm is equal to, it should be root 2 Vs by root 2 pi minus alpha, where alpha is equal to 45 degrees. In that case, we can write this alpha in terms of pi as pi by 4 plus sine 2 into alpha is 45 degrees. In that case, we can directly write this as sine 90 degrees by 2 whole to the power of 1 by 2. In that case, V0 RMS value will be about 155 volts. Since we have got V0 RMS, if we can find out the value of resistance, in that case, we can find out the value of power absorbed by the heater. So in that case, resistance is equal to, we can obtain this by Vs square by P, since power is given in the formula. So here Vs is 230 volts given, 230 square divided by power is 1 kilowatt. Let me write it as 1000. In that case, the value of the resistance will be 52.90 ohms. If you resolve this, we get this. And this is the value of the resistance which is given in the problem, 52.90 ohms. And since we have got both, so power at 45 degrees is equal to V0 RMS square is 155 square V0 RMS square divided by the resistance value is 52.90 ohm. In that case, if we resolve this, we get power at 45 degrees is equal to 454.1 watt. Similarly, we need to find out the power at 95 degrees, for which we need to find out the V0 RMS. If we substitute the V0 RMS here in formula, that is Vm by root 2 pi minus alpha plus sine 2 alpha by 2 whole to the power of 1 by 2. In that case, we get V0 RMS is equal to for 95 degrees, we get it as 115 volts. 115 volts. In that case, this is the V0 RMS for alpha is equal to 95 degrees. In that case, we need to find out the power absorbed by the heater at 95 degrees. In that case, this will be V0 RMS square by R, where V0 RMS is 115 whole square divided by the value of the resistance which we have got is 52.90. And we will get power as 250 watts. This is the power absorbed by the heater at 95 degrees. This is how we can solve the problem. And then we have the third problem as a single phase half wave controlled rectifier is operated from 120 volts 50 Hz supply. Load resistance is 10 ohm, and if the average output voltage is 25% of the maximum possible average output voltage, in that case determine firing angle, RMS and average output currents. So here this is a single phase half wave controlled rectifier which is operating from Vs is equal to 120 volts, frequency 50 Hz, load resistance is 10 ohm, average output voltage is, he's saying 25%, V0 average is 25% of maximum possible average output voltage. In that case, first thing he is asking to find out is firing angle. Second bit, that is I0 RMS as well as I0 average, we need to find it out. Okay, so here in order to find out the firing angle alpha, firstly we need to find out this V0 average maximum. See here, V0 average is equal to Vm by 2 pi into 1 plus cos alpha. This is the formula for single phase half wave controlled rectifier with resistive load. In that case, we need to find out maximum possible V0 average. Maximum possible V0 average. When this particular thing will be maximum possible V0 average, this will be maximum possible V0 average when alpha is equal to 0. So, maximum possible V0 average will be at alpha is equal to 0. Cos 0, the value will be 1. 1 plus 1, it will be 2. And this 2 gets cancelled. In that case, V0 average maximum is Vm by pi. So here, since he is saying find out firing angle at V0 average is equal to 0.25 times of V0 average maximum. V0 average maximum is here Vm by pi, where V0 average is equal to, we have the formula, that is Vm by 2 pi into 1 plus cos alpha. And now we need to find out this value of firing angle, for which let us cancel this Vm pi. In that case, if we resolve this equation, we get firing angle as 60 degrees. Since we have obtained this firing angle, second thing is we need to find out I naught RMS, where I naught RMS is equal to V naught RMS by R. We need to find out the value of V naught RMS first, where V naught RMS for single phase half wave control rectifier with resistive load formula is Vm by root 2 pi into pi minus alpha plus sine 2 alpha by 2 whole to the power of 1 by 2, where Vm is nothing but root 2 times Vs divided by root 2 into pi minus where alpha is equal to 60 degrees. So let me write this in terms of pi as pi by 3 plus sine 2 into 60 is 120 degrees, 90 plus 30. Okay, let me write this as 120 degrees by 2 whole to the power of 1 by 2. V naught RMS. In that case, if we resolve this above equation, we get V naught RMS as 76.09 volts. We got V naught RMS as 76.09 volts. In that case, we need to find out I naught RMS, where I naught RMS is equal to V naught RMS by R, where R value is given as 10. In that case, 76.09 divided by 10, we get as 7.61 amperes. This is I naught RMS. Similarly, he asked us to find out I naught average as well. So, in order to find out I naught average, we need V naught average divided by R. What is the formula for V naught average? We have Vm by 2 pi 1 plus cos alpha, where V maximum is equal to root 2 into Vs is 120 given, 2 pi 1 plus cos 60. In that case, we get V naught average is equal to 27. V naught average is equal, if we resolve this, we get V naught average is equal to 40.534 volts. Once we get V naught average, we can find out I naught average, which is equal to V naught average divided by resistance, where the value of the resistance is 10 ohms. In that case, we get 4.05 amperes. And then we have the fourth problem as half wave control rectifier has a purely resistive load of R and its firing angle is alpha is equal to pi by 3 given. You need to find out rectification efficiency. And second thing is we need to find out form factor. Third bit is he is asking us to find out the ripple factor. And the fourth bit is transformer utilization factor. And the fifth bit we have is peak inverse voltage. And firstly, how to find out this efficiency. Efficiency formula is output by input. And since this is a rectifier, output is DC. So, PDC by input is AC. That is the reason PAC. And how to find out PDC? PDC is equal to V naught average square divided by R. Similarly, AC is V naught RMS square divided by R. Here R gets cancelled. So here V naught average square by V naught RMS square. And if we can find out V naught average as well as V naught RMS, we can find out the efficiency. So what is V naught average formula? We have as far as single phase half wave control rectifier with R load, we have Vm by 2 pi 1 plus cos alpha, where alpha is equal to pi by 3. In that case, we get V naught average is equal to, if we resolve this, 0.39 times of V maximum. That is your V naught average. And V naught RMS is equal to, we have a formula that is Vm by root 2 pi minus alpha plus sine 2 alpha by 2 whole to the power of 1 by 2. In that case, if you substitute the value of alpha, that is pi by 3, and if you resolve this equation, we get V naught RMS as 0.485 V maximum. This is V naught RMS. And since we have got these both, we can find out the efficiency. That is, efficiency is equal to V naught average square divided by V naught RMS square and if you solve this, we get efficiency as and then the second bit he is asking us to find is form factor. Form factor formula is equal to V naught RMS divided by V naught average, where we have these both values, that is V naught RMS is equal to 0.485 V maximum divided by V naught average as 0.239 V maximum, and in this case we get form factor as 203.3%, 203.3%, that is form factor. And the third is ripple factor. In order to find out the ripple content, so here ripple factor formula is given by root over form factor square minus 1, where we get ripple factor value as 177%. Similarly, we need to find out the transformer utilization factor, and the formula for transformer utilization factor is given by PDC DC power by Vs into Is, where PDC is nothing but, we have seen the formula already, V naught average square divided by R, and Vs is nothing but root 2 times of Vm, root 2 times of Vm into Is is, and here Is is equal to V naught RMS divided by R, and if you resolve this, we get this value as 16.6%. Similarly, the last thing is peak inverse voltage. Peak inverse voltage formula is Vm, and this is the peak inverse voltage formula for single phase half wave control rectifier with resistive load. Thank you all.